Alright, so we're going to continue. Okay, first of all, I should make some changes here. I should define it extern const window, so that is a const reference, and I'm not really using a renderer, so get rid of this, and same with this. Okay, I'm making it a const pointer so that we cannot really mess with its value. Okay, I'll also create an external const. Okay, and I'll also declare this. And then we can just have these defined externally. Okay. Right. So then I can simply show it here. With this object, data stream should also be defined. Okay, but I'll go into this function run. I'll go into main function. Okay, I want to, what do I want to do? So basically this works. So I'm going to define a const window, this, right? All pointers will be better for me. The new data stream object variable okay. So right, so we go here and we initialize these as this. So it will just point to this pointer and nothing else, right? And this should work for the most part. Okay, I have not yet defined. Okay, so after check, define the dimensions. Go const screen width equals 800, and then const screen height equals 600. Okay, and screen height, screen width would have shown, and there we go. So this should work. Right, so screen width, oh sorry, const int, and what is it? Expected window, but argument is type const int. Okay, so error. I will make it again. Okay, data stream error conflicting. Oh shit. Okay, and okay, so maybe I should pass in a, let me go to the definition of this function. Right, There we go. Maybe I should rebuild the tags. Yes, here. And I'll say we should create. Where does it say? Window render, right? In the window render function. Let me go here. Where is the window render function? Let me go to its definition. Okay, this is the definition, so I can just go const window pointer. Then I want to go to its reference. These are only references. I think I would have to go to window.h. Okay, so console source window.h and let's make it a const. Single pointer, and I think I should do this as well with the texture, right? Oh, it's okay, but I should pass in a const window. Anything else? Anywhere else? I'm passing a window. There we go. The const. Go with the const and this is okay, I hope. And data stream. Do we take in a window? No, we don't take in a window. Streams. Okay. And let's Windows. Okay, error conflicting types, right? Texture.h, and I have to update all of these two. Const. Then we go here, make it a const. Again a const here. No man, what am I doing? Then go to the definition here, right? So I want to go here and I want to add a const here. Then I'll jump back. I want to go to its definition and add a const here and here. So then I want to jump back. Here else I had put const. Yep, there we go. Jump to its destination. Put a const. Jump to its destination. Put a const. Anything else? No. Okay. So finally I can get here and there should be no more problems. So let me clean it up. Data stream. Okay. Right. Okay, this definitions, right? Okay. Extend telescope surface is okay, it expects a simple. It does not expect anything else. Okay, so the TDF font. Okay, there can be more than one font, so I'll just go ahead and update it. extend const data stream. Okay, maybe I'll just define a single data stream, and we don't need to make it const. So there we go, this is fixed. And window.h, let me go to its definition. Let's put a const and go to another window. Const, I think I have added const here, and then const, and that's destination. I've added a const. Right. Okay. So this bad boy should work now. I will make windows. Okay. And there should be no problem. Okay. Yep. Right. Assignment. Okay, read only. That pointer is read only, and I cannot assign it. Okay, so it makes the pointer, if a pointer is const, it makes it read only. Okay, then my bad. Is it done? Okay, that is all. That is all. No. Okay, so might as well. Right. Okay. So I think I can at least make these extend, right? Extend. Okay. Then I have turn window. Then we don't really need a renderer. Get rid of this. We don't need these values. And then turn and bool quit equals false. Turn bool quit. So okay, so now we can go and define these values. Yeah, Windows this streams this, stream this, data stream equals null pointer. Okay, it has to be a global. Okay, stream destroy. I should close the stream. Have I defined stream destroy yet? No. So I should define stream destroy. Destroy. Then void data stream equals destroy data stream. Okay, so we'll go if stream, it is a valid pointer. Point I equals 0, I less than size of, there you go, images. I just plus str free surface on stream images of I, and that is all. Right, and that is all. Okay, as you can see, and is there anything else? Get buffer will get the buffer. I want to destroy this thing at the end. Right, so window destroy. Close the stream. Data stream underscore destroy. We pass in the stream. And if it's stream equals null. Stream equals null ptr, and then I want window to be a null pointer as well. Okay, so we go window stream window events, and there we go. Okay, so next w windows. Ooh, window create too few arguments. Oh, too few arguments. Window create texture streaming. Window create, and then screen width is const char title, and then still free surface warning. Iteration invokes 4 undefined behavior. Right. Okay. Right. Because I should also check if these are if stream images of I, then we can free them. If there is nothing, then don't free it. Right. So we go make windows. Still this is undefined behavior. Ha. Okay. And I have information in it. Const ttf. Do I still have a const? I don't have a const reference. Okay, expect. Right. Yeah. Okay. So window.c. Have I removed const? Texture. Right. Okay. Great. So that is it. Let's clean W and then make windows again. Okay, so right. Okay, so the only thing that is wrong here is okay, iteration 4 invokes undefined behavior. Okay, if stream images are fine not within the loop size of stream dash images I less than I plus plus. Okay, so this is undefined behavior for images. Okay, so go 4. So is this any better? Nope, nothing. It is not better. Okay, undefined reference to screen height. Right, that I can fix. I can define the dimensions. So I'll go with const int. Okay, quit, also quit is not defined. So init, let me go run r equals init while not quit. Defining quit. So I'll go bool quit is not bool quit equals false. Can quit here while not quit. This is a global variable. Okay, then another set of global variables that I have to define are these: const int screen height 800, 600, and height and width. Okay, I've done some. Okay, height. Okay, undefined. It says undefined reference to screen height width, and then undefined reference to window. Undefined reference to window. Right, I have to define these. Okay, window equals this, and I have a stream here. Okay, then we have any undefined references. Yes, quit, undefined reference to quit. Mention render. Reference to window, then run. Okay, I think it should be fixed now. Let's see. Okay, still undefined reference to window. Extend window. I have defined. Okay, I have defined. Okay, but the function doesn't know, right? Okay, so these globals must be declared first. Okay, so actually this was better this way. All pointers using PTR. Okay, then I don't have to define these. I can just go window and this, right? Okay, so window destroy, string destroy, and there it is. So basically wasted time doing nothing. We still get the same thing, right? Did something wrong? I've quit the window. Oh, because I think is the quit variable set or not? Ah, because I have done one stupid thing right here. It is using that quit, not the global quit. This quit, right? So that is the thing. I have to explicitly, okay, close it. And now let's make it again. And it should be okay, great. Yeah. Alright, so we move on to next definition. As you can see, all this function does is create a 32-bit RGBA texture with stream access. One thing you have to make sure when creating your texture is that the format of the texture pixel matches the format of the pixels for streaming. Okay, then we have locked texture. We have texture is already locked. Okay, if pixels are not null, then we have the texture is already locked. Okay, so if raw pixels, I think new function should be defined towards the bottom. Right. Okay. Okay, then we have void, not void, bool. Bool texture, lock texture. We have a lock texture. Let's see how is it defined. Can I jump to its definition? This is lock texture. Lock texture. So this is bool. Right. This is a bool lock texture. Let me just go ahead. Bool lock texture and bool unlock texture. Bool unlock texture. Okay. Then we want to check. So we first check the texture is already locked. If the pixels are not, then check texture raw pixel not null. If they are not null, okay, raw pixels are not null. Here we go. Okay, but we don't want to. I'll send it in debug. Okay, so we have texture is already locked. Info texture is already locked. And we can define an error of return false, never return true. New texture is already locked. Then we have else we lock the texture. Else we lock texture. Okay, should not be equal to 0. Okay, so I can int lock equals stl lock texture, and we provide a texture, then we pass in a null and the address of a raw pixel. Okay, so a pointer to a pointer, void star star. Okay, so we want let's say what do we want. I want address of texture raw pixels, then end raw pitch. texture, raw pitch, right? And then we check enable to lock texture. This is lock should not be 0. Error unable to lock the texture. SCL error SCL get error SCL get error. Okay, and that is all. Locking the texture, define texture with this format. When we lock texture, raw pixels and raw pitch. Okay, then unlock pixel. This is full texture. Unlock texture. I hope. Okay, there we go. Right. We take in the texture. Then we have raw pixels. Should not be null. Texture is not locked. Texture is not locked. Success is false. Okay. So if it is not null, okay, if it is null, if this is null, that means texture is not locked. Texture is already, if it is not locked. Okay. The texture is already locked and we cannot lock it. And if it is not null, okay, if it should be null. Texture is not locked. Then we set it null. Okay, if it is already null, check this should not be null. Okay, and raw pixels, texture is already locked. Okay, hold up. So I checked that raw pixels not null for. So okay, I say, so before locking, I want this condition to be true, right? That raw pixels should be null. If they are not null, right? If m pixel are not null, then we say that texture is already locked. So we want that m row pixels are null, right? So I assert that these should be null, and if they are not null, it means the texture is already locked. And here I assert, so I should just put it in a check. So we have unlock, so texture is not locked. If m row pixels equals null, we say that texture is not, if they are null, then we say that texture is not locked. Okay, now okay, raw pixels should not, texture is already locked if these are not null. Okay, texture is already locked. So okay, so this condition is false. So we want this to be true, right? Okay, I'm right. Okay, see, if we want this to be true, only then will this will have a non-null value, and then we want check texture raw pixel should not be null. So info, the texture is not locked. Texture is not locked, and then we unlock the texture. We want the statement to be true. Unlock the texture. So simply for STL unlock STL unlock texture. Was it the L capital? Have I put L capital? Yes. Okay. Unlock texture. STL unlock texture. We'll go with texture. And then we want to set raw pixels to null and raw picture. Texture raw pixels equals null and texture raw pitch equals null. Okay, then that is it. We return true. Return false. I want to set some checks here. Check texture should not be null. There you go. It should not be null. So error. It's an invalid texture, right? Invalid texture. Let's copy the same line. Okay. Here are texture locking and unlocking functions which wrap these functions. The STL lock texture grabs a pointer of pixel data, and the pitch of the texture. Notice this pointer is not expected to have the data from the original texture. It may do so on certain platforms like Windows, but on other platforms like it will not. If you create a texture and then lock it, do not expect it to have the original pixel data you created it with. Expect STL lock texture to give you a fresh pixel pointer to send new data to the texture with. The STL lock texture also grabs texture pitch and bytes. Okay. Once you're done manipulating the pixel pointer with the data you want, unblocking it will send the pixel data to the. Okay, once you're done manipulating the pixel pointer with the data you want, unlocking it will send the pixel data to the GPU. Okay, so STL lock texture grabs the pointer of pixel data and pitch of the texture. Okay, let's see the function. This function grabs the pixel data and pitch of the texture. Pixel data and pitch of the texture. Okay, this pointer is not expected to have the data from the original texture. Okay, it may do so on certain platforms like Windows, but on other platforms like Mac OS it will not. If you create a texture and then lock it, do not expect to have the original pixel data you created it with. Expect STL lock texture to give you a fresh pixel pointer to send new data to the texture with. Okay, so this function. Okay, no, I don't. Okay, STL lock texture grabs a pointer of pixel data and the pitch of the texture. Grabs it. This pointer is not expected to have the data from the original texture. Okay, this pointer. Okay, raw pixels is not expected to have the original pixel data of the loaded texture. Instead, STL lock texture will provide a new pointer to the pixel data of the given texture. along with the pitch, which is in bytes. So do we divide it by 4? No. Okay. So we have raw pitch. Okay. To divide it by 4 to get the height, but this is raw pitch. And okay, then okay, unlock. Once you're done manipulating the pixel pointer with the data, unlocking it will send the pixel data to the GPU. Okay. Once we have manipulated the pixel data for the texture, unlocking it will send the data to the GPU. Okay. So copy raw pixels, void we provide of pixels, and we copy raw pixels into pixels and mem copy. Let me go man pages for mem copy. Okay, so mem copy. We have destination and source and have a size. Okay. Then I have copy. Right, get pixel. Where is the copy? Okay, there we go. Copy raw pixels. Then we go void pixel, copy raw pixels 32. Right, copy raw pixels 32 of type picture, and right, copy raw pixels and void pixel. Then if texture is locked, I don't want it null. Copy to locked texture, raw pitch. Okay, here is the function to copy in the pixels from the stream into a locked texture pixel. Okay, the function assumes that the pixel are from an image of the same size as the texture. Okay, that is why we have this. We have white pixels. Then we go in this function, we copy the raw pixels from the stream into the locked texture. The function assumes that the size of the image is the same as the dimensions of the size of the texture. Okay, so let's check. Should not be null. Error. Invalid texture. Then invalid texture. Then we check. Pixels should not be null. Invalid pixels. Then we check. make sure the texture is locked. Okay, so raw pixels should be null, locking the texture. If they are null, okay, we say that they are null, and if they are not null, then texture is already locked. Check here, texture should not be null. Error, texture is not locked. Okay, texture is not locked. Right. Okay, so we check that texture is locked, and then we copy memcopy. Okay, where is this memcopy defined, in which header file? libc library libc. Any header I need to include string.h. I think bcc if includes the string.h, so I can memcopy mcpy copy buffers. So I go the raw pixels. Okay, so this is the destination, this is the source, and this is the size. So we have source, sorry, destination, source, and the size. This is a pixel, raw pixels, and that is it. Okay, so error return. This is fall through. Okay, here's a loading function to copy pixels from stream into the locked texture pixel. The function assumes that the pixel assumes that the pixels are from an image the same size as the texture. So then we go on to the data stream.c stream. Okay, is this correct, right? Okay, I just want to make sure. Raw pitch is equals to null. Okay, raw pixel. Alright, raw pixels. Raw pixels. This is 0. Pixels. And raw pixels. Right, raw pixels and raw pitch. Okay. Raw pixels and then here raw pitch into. Hope this is okay now. Okay, great. And I don't get any warning regarding this. Right, just then we free these. Okay, no undefined behavior here. Alright. And I should also set it to null. Stream image of I equals null. This should be better. Then we data stream dot load media. Okay. Load blank texture of 64 by 245. Okay, I still have one function to define, which is get buffer. So I think I can ask pixel. Wait, let me go to STL wiki. Yeah, let's take to the front page. Right, so I want to source code installation functions. No, not function struct. Is surface struct. Surface. Yes. Surface, and I have pixels. Okay, so I can return these pixels, right? Pixels. I bet this is what he was doing, but just to be sure, I'll download the source code. Okay, I'll take a quick look at this. Okay, I'll texture. We have data stream. Have you defined this function anywhere? I don't get it. Get buffer. Okay, there we go. So yeah, basically we are returning the pixels. Returning the raw pixels. Delay frames. Delay frames. I think I have set the delay frames is 4. Right. Okay. Then I also have to define this real quick. Data stream get buffer. So we decrease. Let's check the stream. Checking the stream. I'm not checking the stream. And this is okay. Right. Okay. Then we simply looping through the images. Stream. What is this? Delay frames. Then we go if delay frames is this. Current image is right. Okay, you know what I can do is current image. Okay, let's do it how he does it. So I think my way would be a little better. If you know, okay, delay. I'm not going. Alright, I'll just go int current frame equals 0. Not 0 because that needs to be global. Okay, that is why we used frame delay frame, and then we have what is okay. So basically the code that I had before. If stream of delay frames equals 0, then we increment the current image. Hope I'm referencing the right one. The current image delay frames and delete frames set to 0, and then delay frames equals 4. Then we check if stream of current image equals 4, then we set current image to 0. And we simply return stream images stream current image, and from that, let me enclose it like this, and from that I want the pixels. So images, current image, and from that the pixels. So we'll get the pixels, then we can go on to game.c, and we can do something like this. Now we load texture, we create a blank texture. I think I'll stick to null for better compatibility, right? Stick to null. Okay. Should be null, and okay, let's just a bit. Then we load in the create the blank texture. Sorry, so we create blank texture because this is the streaming texture. Okay. So I'm going to create texture. Okay, hold up. Does this go up here? So texture create bool. I want to create a texture and create blank texture. Okay, create blank texture. Texture window. Right, okay, so I'll create a texture first. Right, so texture, streaming texture equals null. So I want to go create a texture. I'll go with streaming texture equals texture underscore create. jump to its definition. Sorry, texture. Isn't there anything called texture underscore create? Texture underscore create. So why didn't you take me here, dude? Okay, so we get texture, we set this to result, this to, and those are undefined. So I think result, raw pixels are null, and result raw pitch. I think I've added, okay, raw pitch. Okay, we calculate the pitch, get pitch 32 data from the surface, pixel surface now, raw pitch equals 0, and then that is all right. Okay, so we create new texture, check, texture should not be null, error, fail to create texture. Let's put exclamation mark here. Okay, then we create a blank texture. So I'll just go $r equals texture underscore create blank, right? Create blank. Let's jump to view on the texture, the window, the size, width and size. So streaming texture window, this 64 by 205, I suppose. Right, 64 by 205. We check, or should not be false, and error, fail to create a blank texture. Then we load and stream data. In our media loading, we create a blank texture streaming and start our data stream. Okay. So first we lock the texture, we copy the pixels, and then we unlock the texture. Then we unlock the texture and then we simply render it, okay, in the middle of the screen. Okay, so when it copies, copy. Okay, so width and height are already set, right? If I go to its definition, we set the width and height explicitly. That's good. So here I just have to render this. Okay, so we go copy frame from buffer, copy frame from buffer. We go texture, lock texture, streaming texture, right? Yes. Then I want texture copy pixels. Is there a function named copy pixels? Texture copy pixels, copy raw pixels 32. Yes, copy pixels. What happened to copy raw pixels 32, my man? There we go. Copy raw pixels 32. String texture dot copy raw pixels 32. I suppose it is the same function. but just to be sure, let's take a look. Okay, so there we go. Copy raw pixels 32, and there's no other copy pixel. So load. Okay, where is the main function? Is it in the end? Okay. Copy raw pixels 32. Okay. So we have texture underscore copy raw pixels 32, and then we get the data stream underscore get buffer. How this mission is defined? Yeah, get buffer. We provide in a data stream. So we provide the stream, and then we unlock the texture underscore unlock texture, streaming texture, and then we render the texture underscore render underscore render. We need the render the window. Okay. I should close this. Yeah, okay. So I need the texture, the window, and I think x and y coordinates, which are screen width minus. Okay. Get width divided by 2. Then we have simply get width streaming texture. Same thing here, but with the height. Height. Okay. Hope I'm right. Okay, and there is the additional clip which I have to. Right. Let's try and run it. Okay, we got an error. Check stream not null. Error use data stream dot c ex42. Okay. Right. Okay. So return null. Get buffer. Oh, images. Sorry. Okay. 88 images. Let's see if it will work. Okay. Texture raw texture underscore copy raw pixel 32. Too few arguments. Okay, I also need to provide right. I also need to provide the texture, which is into which we will copy the. And now I hope. Yes. Okay. Error. Okay, it is throwing an error. Unable to lock the texture. Okay. So it is being thrown at texture.c 333. Okay. check lock. Okay, it should be 0. Yeah, that is the problem when we lock the texture, right? I think, right. Okay, if it is not 0, then we have a problem, but it should be 0. We set that clear, W, and then make Windows. And there we